Hello, and welcome to another episode of Earth911's Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable carbon neutral society. And I'm your host, Mitch Ratcliffe. Thanks for joining the conversation today. Wasted energy flows into the environment all over the world. In other words, what we do is what our grandmother used to remind us not to do, which is warm the outside. We heat things up and then we send all this heat out into the environment. And in fact, an immense 247 trillion gallons of wastewater heated to an average temperature of 60.8 degrees contributes to warming local waterways and the oceans all year long. We could recapture the heat energy in all that wastewater for other uses before returning the water to rivers, lakes, and oceans. The process of harvesting that lost energy is known as wastewater-energy-transfer, or WET, W-E-T. A study by King County, Washington found that reusing heat captured by WET systems reduced the carbon footprint of an office building by 34% and the footprint of a mixed-use building, like an apartment building, by 71%. Our guest today is Lynn Mueller, CEO of Vancouver, British Columbia-based SHARC Energy. SHARC is spelled S-H-A-R-C. SHARC Energy is a pioneer in WET technology. SHARC's first system was installed by the city of Vancouver, and among other projects SHARC is working on, they're blending their WET technology with geothermal sources of energy to provide renewable heating and cooling energy, along with the hot water needed by residents of a 316-unit affordable housing project in the Bronx section of New York. WET technology is installed to allow warm sewage to pass through a thermal exchange system that captures it, pulls the heat energy out, and transfers that energy for use generating electricity, warming water, and building interiors. Once cooled, the sewage continues to a water treatment plant as usual, where the sludge extracted can also be converted into biofuels or other minerals for use in manufacturing, and then reintroduced into the environment without contributing to the thermal forcing of river and ocean temperatures. These systems are extremely efficient. WET energy costs 20% as much as generating the same amount of energy from traditional sources. You can learn more about SHARC Energy, which is publicly traded at sharcenergy.com. That's C-A-R-C energy.com. No space, no dash. Well, let's get into the conversation. Welcome to the show, Lynn. How are you doing today?
Great, beautiful Vancouver morning here, sir. And very nice to meet you.
Well, spring is starting to arrive here in the Canadian Southwest and the U.S. Northwest. It's good to see it. I wanted to ask first, how did wastewater energy transfer become your life's work? And of course, the basis for launching SHARC.
Yeah, it's a pretty simple story. I retired from a long career in the geothermal heat pump industry, and spent a couple of days at home and realized that that wasn't for me. So it was kind of the longest 3 days of my life. But while I was there, Mitch, I found that we were spending about $100 a month just on hot water, because up here in Vancouver we heat our house with a heat pump, and I have a natural gas hot water tank. So I knew that, $1,200 a year was leaving my home. And I just, kind of posed the question to myself, why can't we get that back? And then I walked outside and thought, I'm in a subdivision with hundreds of homes. Everybody's throwing away $100 a month. There's got to be a business opportunity. And that's really where it came from.
Well, I'm glad you retired for 3 days. That was an important insight. So it is so true that, and I said this in the opening too, we used to be admonished about heating the outside, leaving the door open, but that's basically what we do with hot water, is spend a lot of energy and then pump it out almost immediately where it warms the environment. So how does a WET technology reduce a building's carbon emissions generally? And then we can talk about other ways it creates savings.
Yeah. So every day in a building, an apartment building, you've got everybody gets up and has their shower and, does that. And all of that hot water goes down the drain. You've spent all that money to heat the water up to 140 degrees, and then you just throw it away. So what we do is we intercept that stream to the sewer line, and we just remove the heat. And there's more heat than you need in there to make your next batch of hot water. So what makes it work for us, sir, is that it's around 400% efficient. So for every dollar you spend, you can recapture $4 worth of heat.
So if, for instance, even when we get to a renewable environment where we're using electricity to heat that water, we could still be recovering that and relieving the grid of the demand for more electricity to heat more water.
Exactly. So what we do is, you mentioned electricity. So if you have a normal hot water tank, the elements in there are about 4 kilowatts an hour. So what we would do is recover all that for 1 kilowatt an hour. And one of the most attractive features too is that you can stage it to match the grid pattern, so you're not overloading the grid at the peak times of the day.
Oh, interesting. So the whole idea of coordinating the flow of energy through the economy is something that we also need to be rethinking.
Yep, exactly. And a big part of our system works because we have storage of both the wastewater and the produced water, the hot water. So we're not really sort of time of day sort of need for it. So what we've learned over the years is that before COVID, everybody used to get up at 6 o'clock in the morning. There was a huge rush between 6 and 9, and then nothing till noon, and a little bit then, and a little bit in the evening. But that's kind of all changed now. There must be a lot of us working from home and stuff, so the load's pretty balanced, and we're really good at recovering that waste heat.
That's interesting. I mean, that we're already sort of adjusting, and we haven't even thought about it in the context of needing to make the adjustment. So let's get into some practical questions. How's a wet system integrated into building? Does it take a lot of space, or does the space scale based on the size of the building?
Yeah, very much so. But so we have two products. We have a SHARC, which stands for sewage heat recovery. It's not really named after the fish, but once we went down that road, then we came up with a piranha unit, and it's a smaller unit based, we'll do just a single building. And so what we need to install is a tank to catch the wastewater that's leaving the building. And if you got 100 suites, you're going to have to store maybe 2,000 gallons of wastewater. And then we have the piranha unit, which is kind of the size of the kitchen table I'm working on here today. So all in all, it takes about the same amount of space as one parking spot for all of our equipment. So it's bigger than you could probably put in an existing mechanical room, but not so big that it would fill the parkade or anything. So,
all right. So now, in addition to our homes and our offices, industry represents a vast source of recoverable power and energy. Are you also looking at how to co-locate wet technology with various industrial settings?
Absolutely. And I was out in Portage La Prairie, Manitoba, a few months ago to a French fry making facility. And oddly enough, they use a lot of hot water. So they used about 1.5 million gallons of hot water a day. So much so that it was so warm they couldn't put it into the sewer until they cooled it. So they were paying to heat it, use it, cool it, and then discharge it, and weren't recovering any heat. So we can go in there and make a very phenomenal case. Like the payback was sub 2 years on that job.
Right. Wow. Now that's the kind of economics that are really transformative in terms of thinking about an investment for a green outcome and actually seeing one. Now, I want to turn to your biggest project. You're working in Vancouver on the False Creek Energy Utilities wastewater recovery project. And this is a vast undertaking, 6.4 million square feet of residential, commercial, and institutional space. How much energy is being generated and how much CO2 is being avoided by that project on a monthly basis, for instance?
Yeah, well, monthly. So it's going
whatever number.
Yeah, it's going to be about 10 megawatts per hour. So a normal home uses about 1,000 or so kilowatts a day. And so this is like 100 times that size, or no, 1,000 times that size. Yeah. So it's massive. It delivers heat for about a 5-mile loop around all the way down 2nd Avenue from Cambie Street to Clark Street, if you know Vancouver. But it's hard to believe. And there's a wastewater pumping station under the Cambie Street Bridge. So that's where they built the wet system. And they supply heat and hot water to the development now. But we're also just shipping them right now 5 more SHARC units to expand it to go to 22 million square feet of heated space, heat and hot water.
So this is going to cost about $100 million. How long will that system take to break even financially? And in terms of the carbon footprint of all the embodied carbon in the material that you're installing?
Yeah, that's one of the embodied carbon count is really something we're super proud of because we're made locally here in Vancouver. So our payback on the embodied carbon count is virtually months, not years. So wow. The amount of output from a small unit is just staggering. But the payback on that investment, I think it was quite a bit more than 100 million by the time they've expanded all this time. But it was built in 2010, and it's already broke even in generating income.
So that's the largest project in North America, but this is a technology that has been used in other cities and sometimes for decades. Tell me about Stockholm's approach, because they're heating 80% of the city by recapturing wastewater energy.
Yeah, it's amazing, Mitch. I was over there and looked at a lot of their systems. But what they do in Stockholm is they use a different method to treat the wastewater. So here in North America, we use an anaerobic treatment system. So we use bugs to digest the material. But over there, they use aerobic. So they can use the discharge water that comes out clean at the end of the process for heating and cooling. Here we can't because the bacteria lives on and fouls heat exchangers.
Oh, so okay.
I don't know why, there's 2 different kinds, but I was over in Stockholm and visited their plant there, and it's the size of 5 football fields underground. And it doesn't even smell. Like, it was amazing. Here, not quite so smell friendly.
How long have they been doing that?
40 years, maybe.
So a proven technology, and we have AC and we have DC, so to speak, the way we organize it. Do you see an emerging standard, or will there be sort of a spread of this and a lot of different species of wastewater recovery?
Yeah, I think so. And there's so much chatter now. If there's all kinds of groups on LinkedIn and stuff. But just from the calls coming into SHARC, it's a staggering growth, and everybody now is looking for something that makes sense. Like a lot of things, you hear a lot about hydrogen, you hear a lot about fusion. All of these things, but the world would have to have kind of a quantum shift of how it operates for a lot of those things to work. Our technology is maybe just too simple. Heat moves from warmer to colder, and Our system works. And then we use, Willis Carrier invented the first air conditioner, refrigeration unit quite some time ago, and it hasn't changed since then. It's virtually the same. You put refrigerant near the warm water, it absorbs the heat, and then you put it under pressure and it forces it to give it up. And it's, the world's simplest system.
Well, this really kind of brings to the forefront the fact that we have a lot of the technology we need to be more efficient. It's just a matter of deciding to stop being wasteful. And this is what I was really intrigued by with the Bronx project, where you're working on a multifamily complex that uses both wet and geothermal energy to make it completely self-sustaining. How should we be thinking about building 100% self-heating and electricity self-sufficient buildings or a built environment by adding various combinations of wet, solar, wind, or other sources of energy? What's the path forward?
Well, I think collaboration of technologies. So one thing I think that sadly lacks is that we don't get solar working with SHARC and working with wind and we're all trying to cut our own swath through the field, and we don't run into each other. Mm-hmm. But if we collaborated, it makes tremendous sense. So when you talk about the project in the Bronx, by adding a SHARC unit to temper the geothermal system, it was only required to be about half the size. And when you're drilling holes in New York City, it's a very expensive proposition.
So they're relieving the load on the geothermal by reusing the wastewater, which means that there's more geothermal available for others.
Yeah, and just what geothermal is just a storage device for energy. So you're just moving heat into it in the summer, taking heat out of it in the winter. So we just enhance that by using the available sewage to do a lot of the work.
It's really intriguing because as we create more efficiency, we create more abundance that can be spread around, and we can solve a lot of problems. I want to continue the conversation, but we're going to take a quick commercial break and we'll be right back. And we return to the conversation with Lynn Mueller. He is the CEO of SHARC Energy, and we're talking about wastewater energy transfer technology, which recovers heat from sewage for reuse in buildings and in industry. So, Lynn, wet is just one way to recover energy from wastewater, which is packed with a lot of other stuff, let's just say, since we're talking about sewage. But it can be processed or it can be processed into oil or various fuels. There's a lot of potential in wastewater. If we were really to take a completely systemic approach to this project, how much energy could North America recapture?
Well, that's a great point and great question. And about half of the energy used in buildings ends up going down the drain. Mm-hmm. And that half represents about 350 billion kilowatt hours a year of energy. So, $40 billion worth. So if we could just recover that for, the efficiency of 400%. So for $10 billion, you recover 40 billion.
But if you were to add to the wastewater energy transfer energy recovered, all of the processing potential of the materials in the sewage, we're also talking about another entire order of magnitude of recovery. So it just seems to me like we should be thinking about sewage differently than we do today. How would you recommend, or what do you talk about with your customers about the potential of all of the energy in the sewage?
Yep, and we bring up all those points you made, and quite often though the decision is made financially. Are you the cheapest green system? Are you gonna? What's the biggest bang for your buck? And we certainly tick those boxes because we provide heat, air conditioning, and hot water. So we're multifunction. When you mentioned Sweden, over in Sweden at their plants, they take out all the solids and they sell them as fertilizer and stuff. So they really take everything but the squeal, basically. And when you just look at the vast amount, but New York City is a great example, sir, because they have about 1.4 billion gallons a day of sewage. Mm-hmm. And it's all collected. Like there's only one sewer system per city. Yep. So if they were to recover just 1 degree back from that of the 30 or so it's heated from wastewater being thrown away, the cash flow is $3 million an hour.
Holy smoke.
1 degree.
And yet we're talking about 30 degrees potential.
Well, we don't, that's kind of a misconception of what we do. Is we take about 4 degrees out of the water flow. There's just so much water flow that you can't even tell the difference.
Well, so I've been doing some math, and you literally have the biggest market opportunity I've seen in a long time. Commercial real estate footage in the United States accounts for 97 billion square feet. That's 1,500 times the square footage served by False Creek, and then there's another 256 billion square feet of residential space. That suggests that you are looking at literally an unlimited market over the course of the next 50 years. Yeah. How will the cost of this technology change as adoption increases? Will this become a very simple, straightforward economic decision?
Yeah, and it certainly will go down significantly because now everything's custom, Mitch. We gotta get a custom heat exchanger, custom
Right.
is that. So I think as the mass production goes up, the price will come down. But
Hmm.
the value, even at the price we are, the
Yeah.
value is there. So we've got a system in Denver, not too far down the street from you there from Tacoma, and it serves 250 acres of development, heating, cooling, and hot water. So every building has heat pumps in it, and they use the heat. And a BTU of supply doesn't care what temperature it is. So if you supply it at 70 degrees or 150 degrees, it's still the same BTU. Except when you tie all of the buildings together, there's a university, there's a hospital, there's
Mhm.
residential. Well, then you're able to reuse all the energy within the loop because one building might be cooling when the other one's heating. And then you have this amazing, just the net difference between the energies that you need. So I think that's one of the great breakthroughs in energy is a passive net energy loop.
This really requires a long-term view, and I want to ask a little bit about the launch of the company. You started in 2010, and you went public in 2014. How long did it take to develop the basic design, test it, and deploy the first system?
Well, when we started, and I'm a heat moving person, a refrigeration mechanic, so I thought, how tough can it be to use the sewage? And I didn't know a darn thing about sewage. But it took us about 6 years to really get it to work the way we wanted it. And one thing about SHARC is we are the world leader and we just build an amazing product. So it took longer than I had hoped, but really we had to build an industry. I spent hundreds of thousands of miles and telling people about sewage heat recovery, and they all thought I was crazier than hell. And but now we've persevered and we are far from being saturated.
Mm-hmm. Now, but this also suggests that investors need a kind of a long-term view when rethinking the infrastructure. What's your advice to somebody thinking about putting money into projects like this or technologies? What's the horizon that a sustainability-minded investor should adopt when considering it?
Yeah, I think I think all the stars are aligned for us now because we have things like carbon taxes, carbon credits. Price of energy is skyrocketing due to some trouble they're having over in Europe, and we at least buffer your energy requirements by the efficiency of 400%.
Mm-hmm.
So we can't stop electricity from going up in price, but it only affects you 25% as much as it would before. So it's a wonderful long-term investment. And one of the thing that really appealed to me originally is you get to use the same energy every day in perpetuity. So we take the energy out of the sewer line, put it in the next batch of warm water, hot water. You have it for a few minutes, you throw it away. We catch that very same energy and move it back for 20% of the cost, and you get to use it again. And you can't wear it out. Like energy can't be created or destroyed. And crap runs downhill. So we're in business.
Well, and at 10, 15 years of effort and development, you have set the stage for that kind of a transition. But you also just mentioned carbon credits, which represents another form of value that could be used in the financing of these systems. So I understand you're working to quantify the carbon credits that you could extract from running your system. Can the future value of those credits be projected to develop new financing structures for wet upgrades of existing buildings?
Absolutely, and that's one of the things I'm most excited about now. Is I'm just reading an email today about a project we're looking at on where they're willing to pre-buy 10 years of carbon credits, and they'll give you $650 a ton, which is staggering. Everything we do reduces carbon because we're just reusing that energy and the efficiency. So I believe in the future, carbon credit trading is going to be a huge part of SHARC's financial future. And with the IRA money, and Canada just passed a similar bill, we can get about 45 to 50% of the total cost of the job back in tax credits. And they're flow through, so they're very easy to deal with.
So in that setting, you could have tax credits plus the future value of carbon credits to offset the initial investment.
Yeah.
So basically, this could, in the long run, almost be a wash financially at the outset.
Oh gosh, yeah. And there's a list of companies will put up the money to put them in for you. So we work with 3 or 4 companies that are just more than happy to assume all the risk and put them in.
So how are property investors and governments responding to this opportunity? Are they really aware of the environmental and financial benefits of WET at this time, or do they need to learn more?
I think they need to learn a little more, but there's so many seminars. I'm at the student housing conference next week, and there's so many seminars now talking about it. And a savvy developer is, using that tax money to reduce his build out cost and hopefully pass it on to the consumers. So we just did a system here. It's called the Musqueam First Nations band. Mm-hmm. And they developed 23 acres of market housing for anybody. And we just put basically a loop around the property, and it ties onto the sewer line. We keep it at 70 degrees. Every building ties onto it. So their cost of heating and cooling is virtually nothing.
This is a great story, Lynn. I also understand you're seeing a lot of uptake, a lot of sales opportunity, and you're expecting to grow revenues by 500% this year. But what are your challenges as you grow? What are there? It sounds like the incentive programs are all aligned. Where are your challenges?
Well, 12 years later, we're still a new technology. So, I think that is the biggest hurdle. But it's not easy. It can't be used in every building because there's challenges for space. Can you tap into the sewer line? So we're really still perfecting that tie into the city line. We had some huge advancements here with cities like Seattle and Toronto, where they will let developers tie onto the sewer line, give them the infrastructure, and then they pay them a small amount for energy in and out of the sewer line. Mm-hmm. So that's really exciting for us, because now there's skin in it for the cities and utilities. The sewer line used to be just like owning a boat, just a place to dump money. And now it's become a revenue source in places like that. And they have thermally mapped their cities, so developers can see where the flow is. They can see where it makes sense to tie into it and where it doesn't. So, it's a very exciting time.
Well, this is really going to be interesting to follow along. How can our listeners keep track of what SHARC's doing?
Yep, just we're shameless promoters on our website at www.sharcenergy.com, and you'll be sick of seeing my ugly mug, because there's so many videos and stuff on there of talking about sewage heat recovery. So drop in there or call me anytime.
Well, thank you, Lynn, very much for spending time with us today. It's been fascinating.
My pleasure. Anytime, Mitch.
We've been talking about wastewater energy transfer technology with Lynn Mueller, who is CEO of SHARC Energy. And you can find them at sharcenergy.com. SHARC is spelled SHARC, SHARC with a C rather than a K, sharcenergy.com. Sustainability requires that we look closely at the entire system on which our economy is built to identify unnecessary waste, and heated water is a rich source of reusable energy. WET technology is another layer of circular economic value that can be captured to reduce our environmental impact while saving 50% to 75% of the cost of heating water in the first place. What Grandma said is really true. We've been heating the outside instead of reheating the inside for far too long. The economics of WET technology will be a test bed for identifying circular energy flows in other aspects of the built environment. As Lynn explained, WET systems can pay back both the initial financial investment and carbon footprint of the installed systems in a few dozen months instead of 10 or 20 years. When we add in the future value of carbon credits generated by avoiding emissions from heating water, the financial barriers to adoption will fall, and WET will be basically a no-brainer from the perspective of a building owner or a city manager thinking about how to both save money and do better for the environment. But as heat transfer technology evolves, it may not just become cheaper, but also smaller and potentially possible to fit into any home. That's a long-term option, and it'll be exciting to follow the evolution of wastewater energy transfer, one of the many keystone technologies already available to create a sustainable society. We'll certainly have Lynn back on to talk about SHARC's progress. Hey, folks, I hope you take a moment to share this podcast or any of the more than 390 interviews we produced on sustainability in your ear. Writing a review on your favorite podcast platform is a great way to help your neighbors find us, and you are the amplifiers that can help spread more ideas to create less waste. So please tell your friends, family, your coworkers, the people you meet on the street that they can find us on Apple Podcast, Spotify, iHeartRadio, Audible, or any of the other fine purveyors of podcast goodness that you prefer. Thank you so much for your support. I'm Mitch Ratcliffe. This is Earth 911. We'll be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.